In this video, we are going to discuss about the grooving experiment. So, what is the aim of this program is write a part program for a grooving operation in the given sketch using grooving cycle and show the simulation using simulation software. So, the billet size what it is given is 32 diameter and 80 diameter. So, what we are mentioning this is the area where we want to make a grooving. So, in this grooving, we have to make a tool. We have bring a tool here. This is what the grooving tool, and from by using the grooving tool, this entire area to be removed. Okay, when the job is rotated, so grooving has to come like this, and it will move. It will make. We have to make the grooving tool. We cannot make as a turning here, so we have to bring the tool and we have to make the depth in such a case that this 32 has to reduce as 20 for a distance of 12 mm. Okay, so for this a grooving cycle is used. The grooving cycle, the syntax is G75. So G75R and G75XZPQF. So all these terms we are going to use. Retract amount. So the tool once it is made the operation, then it has to move above and it has to move this z-axis and x-axis. So this is what the retraction amount it helps, and xz coordinate is the coordinate points where it is going to start and where it is going to end. This is very important. So this from this area to this area, this grooving has to be done, and p is a step increment along the x-axis. So the how it will move. For imagine that 32 diameter is there and I want to make as a 20 diameter here. So the difference is there. So here the distance is machined by some increment values. Directly the tool cannot enter for the full depth. So we are going to make a little bit increment in x direction as well as in z direction. Once this area is completed, then we have to move to the next. So like this it will be there. So feed rate is F. So for that what we are going to write is O, that is program number first. Let me start with the program number, and this is letter O and a number 1007. Whatever number may be there, we can use a 4-digit number over there. And the billet size is 32 diameter and length is 62, what it is given. And we are going to use for G21 the metric data input, and feed per minute, that is G98, and G40 is the TNRC cancel. So that the TNRC is the tool nose radius compensation, and whether it may be here it's required or not. If it is not required, we need not to write. Okay, so the tool nose radius compensation where it needs to shift the tool from the path, so that we are going to use for the diameter reference. That is what we called as tool nose radius compensation. We will do it. So it's not mandatory here. And G28 U0 W0 is the home position. Always we say a job is here, so this is the raw material and the tool is here. The tool should be starts from the home position always. The home position we call it as the G28 U0 W0. So from there then we are selecting the tool, which tool you want to make the operation. That is the tool selection. The tool is getting located in a tool number station number 4. So it's not, that is also, it depends the tool location. It may be tool number 1 or tool number 2 or 3 or 4, whatever it is. So the number where the grooving tool is located, that tool station we have to select it. So tool number 4, and then it has to rotate. The job has to rotate for operation. So 1200 RPM it is going to be rotated, right? Now bring this tool to position this area where I want to make this is the area I want to make the groove. So this is the area I want to make the groove. So I am bringing the tool to this position. So that is X35 Z minus 33. Why I am saying the Z minus 33 in the sense this is what we are going to select a width of 3 mm cutting width, a tool which is having a cutting width of 3 mm, and it will be located at this area. So this is the 3 mm width. So what we are doing is, instead of bringing to the here it is 30 mm, the length is 30 mm, it has to come. So from here it has to travel 30 mm as well as the 3 mm width. So combinedly it will take 33. So this is the job thickness, and up to this it's a 30 mm and this is a 3 mm. So we have made as 33 z minus 33, and this is the grooving cycle, which is a retraction amount, and up to what position it has to move. So that is x20 is the diameter and 42. See here, this is the value where the tool exactly will lie. At the end of this is diameter is 20 and the distance is 42. So the diameter 20 and z 42 we are writing G75 x20 z minus 42. Then we are going to finish this program by G28 U0 W0 M05 and M30. M30 is the M05 is the spindle stop and M30 is the program stop and restart. So by this way we are going to finish this grooving cycle. And what is the P and Q refers here in the grooving cycle? The P is this is what the increment, X increment and Z increment. So in X, once the grooving is done, so the tool has to, this is the tool, it will move a little. So this is the movement of the tool. So this is the increment. 1000 means 1 mm, that is micron, 1000 micron. After this, then I am moving this tool in this manner, either 1000 micron or 2000 micron, whatever it is. So the tool will just move 1000 microns from this position, then again it will make a groove. So the grooving will be taken care with the help of this incremental and these values. So after this we are going to make, after the program we are going to make this simulation by using the simulation software. Let me see how to do the simulation software over here. How to use the simulation here. So after the grooving process, so this, once the program is written here, then we have to make this grooving process. So grooving, let me go for the operation again. That's the same CNC. You have to select the CNC turn. Once it is open, then here we are going to create a new part, and blank, what is the blank size it is given. So the blank size is the size of the raw material. So 32 is the diameter and the 32 and 20. So here what we are going to do is 32 and 20 we are going to use. This 32 and the length is 80. Okay, 32 is the raw material diameter and Z80 is the length over here. So that what we are going to do is, in this I am going to write the 80 length and diameter 32. Okay, diameter 32, 80 is the length. So this is the blank is over, and now we are going to copy paste what is the program written over here. So I am going to copy paste this program. So the brackets, whatever it is there, it's just for our reference. So this is what we are going to do it, and assure that everything will be in a straight line. So this I am entering that it should not be in the line like this. So it's a sequence program. Assure that the program should be written in the sequence like this. So 0 program 28, and if it is also, it's also not needed this party, and tool number M06 G00 X minus 35, whatever we have written in the program, the same you are going to type here or copy paste here, which is the best one we can do it. And the blank size is given, so this is 80 and 32 for the Z0, and machine, select the machine here, this is the A, and go for the syntax for verification of the program. If the program is there any error, it will show here. If it is not, then now it shows the tool number 4. Why? Because what we have given here is the M06 tool number 4, so it shows the tool number 4. Now let me go for the tool number 4. What we have to select? So here external groove operator. There are external turning, internal turn, boring, everything is there. Then we are going for external groove. So external groove operation, go and select something, and the width here it is 3.1, 10 depth or 12 depth, whatever it is there. I'm selecting a tool with okay. So here you can show the tip width. So 3 mm tip width I am selecting here, and corner radius is given. Hold it there, and the maximum cutting depth, because that is the what here we are going to use the grooving. So the grooving, it should not get disturbed because of this depth, so keep it a more depth over here. And this is a corner where the tool should be, it's not here. We are selecting this corner and give OK, give OK. So everything is okay, left, because we are left only we have concentrated and we have written the program for it. So now we are going for the simulation part. So once this is everything, the tool, blank, machine, syntax is done. So again you can check the syntax. So syntax, it shows 0 error. So once before the syntax is done, then we will go for the programming. And if you do like select this one, step by step only we can do. That is, clicking by this blue color will show what it is going on. So tool selection is done and the spindle starts. Now tool has to come here. This is the position where the tool will come and located here. Then we are going to use the grooving cycle. So X incremental and Z incremental until this, now it is going to be done. Since it's a grooving cycle, so now if I give one click, automatically how it is moving. So X direction it reduces, after that it moves to the Z direction. So we can control this, the movement, by seeing reducing the speed here, and we can see how it is. So this is the end of this program, that is the where the diameter is reduced to 20, and then the distance is done. So what it is done is everything it shows here, and then we are going to start this program and it is going to be saved here. Okay, so this is the program what we have done. So after this program, this is the result of this is we have simulated. So when compare, this is a statement results, what we have to write is a simulation has been done for this given sketch. Okay, so this is over.